The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Alrighty, so today we're going to talk about the slope of a line or the rate of change of something. First of all, we'll deal with the idea of slope. Let's see here. This is not working well. Let's try that again. Yeah, here we go. All right. To figure out a slope, we go from left to right. This line, the slope going from left to right, the line is going up at an upward angle. So we would say that this line has a positive slope going up from left to right. This line is going down from left to right, so we would say that it has a negative slope. When a line is horizontal, we say the slope is 0. And when a line is vertical, we say that its slope is undefined. And we'll look at all this in more detail to kind of determine why, for instance, why does a vertical line have a slope that's undefined? Why does a horizontal line have a slope that's 0? We'll be exploring that further. All right, now, slope is defined as rise over run, or a change. Oops. If I press too hard, it goes to the next screen. A change in y divided by a change in x. Let's take a look at a line that goes through those two particular points. First of all, going from left to right, we see that the line is going up, so it has a positive slope. And slope is defined as rise over run. We're going to draw a right triangle, like so. And we can see that it goes up 3 units and over to the right, 1, 2, 3, 4, 5, 6. Okay, so the slope, and by the way, I don't know why, but the letter M is used to stand for slope. The slope is up 3 and over to the right 6. We can reduce this fraction, so we would say the slope is 1/2. In fact, as we look at the line, we can see that it, for instance, from these 2 points, it goes up 1 and over 2, up 1 and over 2, up 1 and over 2. So the slope of this line is 1/2. Any questions about this particular example? All right, let's take a look at another example. Okay, let's see here. This line, as it goes from left to right, is going down at an angle. So we say it has a negative slope. Let's see, going down and then over, it goes down, what, 4 and over 2. So the slope is -4/2, which can be reduced to -2/1, or just the slope is -2. Technically, slope is a ratio, a comparison of two numbers, But when the denominator is a 1, it's acceptable. In fact, it's typical to write the slope like this rather than that. Anyway, here the slope is a -2. Any questions on this example? Okay. Here we have a horizontal line. There is no rise. So it goes up 0 as it goes over 1, 2, 3, 4, 5, 6, 7. But 0 divided by 7 is 0. So we say the slope is 0. So the slope of a horizontal line is 0 because there is no rise or fall as it runs. Any question about that? Okay. And here we have a vertical line. Well, let's see. Let's go from this point to that point. So it goes up 1, 2, 3, 4, goes up 5, but it goes over 0. Divided by 0 or dividing by 0, whoops, is undefined. That's why the slope of a vertical line is undefined, because when we calculate it, we end up dividing by 0. So again, going from left to right, if it goes upward, it has a positive slope. Downward, it has a negative slope. Horizontal line has a slope of 0, and a vertical line has a slope that is undefined. Any question about those examples? All righty. Now we're going to look at how to find a slope using what's called the slope formula. So I'm going to start off by labeling 2 points. And we'll draw a line through them. Let's see here. Let's see, the coordinates of this first point is -3, 2. And the coordinates of the second point is 2, 5. All right. So I'm going to find the slope without looking at the picture, but rather using the slope formula. Then we'll look at the picture to verify the information. Now, I have 2 points that I've labeled, and I'm going to call them point 1 and point 2. All right. The slope formula, as it is called, says that m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, the reason I'm saying sub is to refer to subscript. So this is y with a subscript of 2 minus y with a subscript of 1, etc., etc. The subscripts refer to the points, as in point 1 and point 2. All right. So y sub 2 would be the y value for point 2, which is 5. Everybody see where I got that? Y sub 1 is the y value from point 1, which is 2. X sub 2 is the x value from point 2, which is a 2. X sub 1 is the x value from point 1, which is a -3. Again, any question about where I got those 4 numbers? So now let's simplify. 5 minus 2 is 3. 2 minus a -3 would become 2 plus a +3, which is 5. So the slope of this line is 3/5. Now let's look at the actual graph and count squares and see what's going on. It's going up, so it's positive. It goes up 3 as it goes over 5, so the slope is 3/5. Now, one might say, why go to all this trouble when you can just count squares on the line itself? Well, for a couple of reasons. One, maybe you don't have the picture, you just have the information. Or two, maybe the picture is difficult to interpret and the information is not nice, whereas we can still do it algebraically rather than relying on the picture. Let's look at some examples of slope using just the ordered pairs. Okay, let's see here. So find the slope of the line passing through the given points. -3, 5, and -5, 6. Again, the directions, find the slope of the line passing through the given points. So I'm going to call this point 1 and this point 2. The slope formula, which is a formula that you will want to have memorized. You'll be seeing it throughout your mathematical career here at YBC and beyond. So let's see here. Y sub 2 is 6. Y sub 1 is 5. X sub 2 is -5. X sub 1 is -3. 6 minus 5 is 1. -5 minus -3 would become -5 plus 3, which is -2. Now, when we have a fraction, we don't leave the denominator negative. We either move the negative sign out in front or to the top. This is equal to this or that. I suggest when writing the slope that you use this form so that you can see that the slope of this line goes down 1 as it goes over 2, down 1 as it goes over 2. All right. Any questions about this example? So if we were to graph these 2 points on a graph, draw a line through them, the slope would be down 1 and over 2 to the right.
Hey, Mr. Mayo,
Yes.
do we always assume that when it's listed that point 1 is the first one they're talking about and point 2 is the second one, and it's left to right if you're looking at the graph?
Thank you for asking. I was hoping somebody would ask that, Courtney. All right. I suggest we always look at the graph from left to right, but let me show you what happens if I switch these 2 points. Let's say that I had done it like this. And I'd call this point 1 and this point 2. All right. So ignoring what's up above there, let's just say, here's the problem. Okay. So y sub 2 is 5, y sub 1 is 6, x sub 2 is -3, x sub 1 is -5. 5 minus 6 is -1. -3 minus -5 is -3 plus 5, which is 2. Voila, you get the same thing. Okay? But I'm glad you asked about that. That's a good thing to know. So basically, I would always pick the point that's starting from the left first and then the one from the right, but it doesn't matter. Either way, you ultimately get the same thing. Here we got positive over negative. Here we got negative over positive, but they still come out the same. All right. Any other questions about that before we go on to some more examples? Okay. Let's see here. Here's one that might be, well, let's do it. Let's do it. Okay. 5, 7, and -4, 7. All right. Again, I'll call the first one point 1 and the second one point 2. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 7. Y sub 1 is 7. X sub 2 is -4. X sub 1 is 5. 7 minus 7 is 0. -4 minus 5 becomes -4 plus -5, which is -9. 0 divided by a non-zero number is 0. So the slope of this line is 0. So let me ask you this, see if you remember. If the slope of the line is 0, is this line going up, going down, horizontal, or vertical? Which one is it?
Horizontal.
Horizontal. Excellent. So this is a horizontal line. Notice it has the same y value. So it would be a horizontal line passing through y equals 7, and then you've got different x values. All right. How about this one? Let's find the slope of this line. Again, we'll call the first point 0.1 and the second point 0.2. Y sub 2 is 15. Y sub 1 is 8. X sub 2 is -2. X sub 1 is -2. 15 minus 8 is 7. -2 minus -2 is -2 plus +2, which is 0. Dividing by 0 is undefined. What kind of a line is this? Positive slope, negative slope, this or that?
It's vertical.
It's a vertical line, right? Oops, vertical line. And notice it has the same x values. So it would look something like that. All right. Okay. Let's say we've got these two ordered pairs, -2.5, 1.75, and -0.5, -7.75. This might be hard to calculate looking at a graph because of the decimals involved. Let's see, this is a 1. So I'll call this 0.1 and this 0.2. Y sub 2 minus y sub 1, x sub 2 minus x sub 1. Y sub 2 is -7.75. Y sub 1 is 1.75. X sub 2 is -0.5, and x sub 1 is -2.5. Well, let's see, in the numerator, I've got -7.75. I'm going to use my calculator, -7.75, and then minus 1.75. So I get -9.5. And in the denominator, subtracting a negative is like adding a positive. So I've got -0.5. Whoops, hang on here, -0.5, and then plus 2.5, which is 2. So I've got -9.5 over 2. Well, with a slope, we either want to have a single integer answer like 2 or -2 or 3, or a fraction with a whole number, or I should say an integer on the top and an integer on the bottom. We could express it as a single decimal, but we wouldn't leave it in this form. Okay, so let's see. A couple of things I could do. One, I could take -9.5 divided by 2, and I get -4.75. And I could say that the slope is -4.75. That would be useful, but not if we were going to use this to graph. It would be easier to have it as a improper fraction or a proper fraction if we were going to graph it. So let's see, how would we turn that into a fraction in reduced form? Well, we could multiply by 10 over 10. And then we could what? Reduce the top, divide the top by 5 and the bottom by 5, and we get what, negative 19 over 4. Let's see, let's check our work here. Negative 19 divided by 4, that comes out the same. Yeah, so if I was graphing, this would tell me I'd go down 19 units and over 4, down 19 units and over 4. If I had an equation and I wasn't concerned about the graph, but perhaps some other information, then this form would be useful, okay? Again, follow the directions. Let's see here. Notice the directions over here on the right in WAMAP. For instance, question 1, find the slope of the line as a reduced fraction or integer, okay? So you wouldn't use negative 9.5 over 2. That wouldn't be considered a reduced fraction. Let's see here. Oh, I know what I wanted to say. Let's see, let's go back. Oh, don't have that example yet. Let's say that we ended up with a slope of 3/2. We did a problem and the slope is 3/2. Even though mathematically 3/2 is equal to 1.5, in the context of a slope, which is a ratio, we would not write it as a mixed number, okay? So keep in mind, slope is a ratio, so we could have an improper fraction, but we would not change it into a mixed number. That would not be a correct notation. All right, let's see here. I want to talk about if we have a line and the equation of the line is y equals some number, let's say y equals 4. If we graph y equals 4, that means that no matter what x is, y is 4. If x is 0, y is 4. If x is 1, y is 4. If x is 2, y is 4. If x is 3, y is 4. If x is 4, y is 4. What do we get when we connect those points? We get a horizontal line. So y equals a number is the equation of a horizontal line. And the slope of a horizontal line is 0. Okay, so an equation in the form y equals a number, the graph would be a horizontal line because you've got a line where all the y values are the same, and the slope of that line would be 0. Okay. Let's say we have the equation x equals -3. So that means that no matter what, x is -3, because no matter what value of y we try to insert into the equation, it's still x equals -3. Well, x is -3 when y is 0, x is -3 when y is 1, x is -3 when y is 2, x is -3 when y is 3. If we connect these points, we get a vertical line. So an equation in the form x equals a number is a vertical line, and the slope of a vertical line is undefined. Okay. Any questions about that? All right. So let me ask you this. What's the slope of the line whose equation is x equals -4? What would the slope of this line be?
Undefined.
Excellent. what would the slope of this line be?
0.
0. What kind of line is this? What does it look like?
Vertical.
And this one?
Horizontal.
Excellent. Good job. You get a gold star today. All right. Hang on just a minute here. Let's see here. Notice, let's look at question 1 here on WAMAP. Notice that it gives you find the slope of the line, gives you the 2 points. Now, if you come up with a slope that's undefined, then you're going to click on that spot, okay? If, however, it's not undefined, then you're going to use this and put your slope in here. Let's do this problem. So we've got -2, -5, and 0, 1. We'll call this point 1 and this point 2. I suggest that each time you do one of these problems, oops, I suggest you write it down correctly for starters. Let's see if I can find my mouse here. And anyway, I suggest you write the slope formula so that it gets stuck in your head, okay? So y sub 2 is 0, y sub 1 is -5, x sub, oh, that's wrong, isn't it? What is y sub 2? It's 1. Yeah, slow down. I'm talking to myself here. Y sub 1 is -5, x sub 2 is 0, x sub 1 is -2. 1 minus -5 is 1 plus 5 is 6. 0 minus -2 is 0 plus 2 is 2. But this reduces down to 3/1, or just 3. So it's not undefined. It is 3. Now here's the bummer. I was hoping to get a slope that was a fraction, and it didn't turn out that way. Let me just do this, okay? If I put in a fraction like that, it says not a valid fraction. But once I put it in the denominator, it works. In other words, I can use that slanted key on the keyboard that's right below the question mark, okay? But I could also use this, okay? I could do it that way as well. So I could do it like this and say, well, it's going to be 2 over and then 3 that way. Of course, oh, that's 1/3. Okay, let's do that. Anyway, so I can write it like that using this, or I can just write it using 1 and then that slanted and then the 3. And then once you finish it, that red warning should go away. All right, you okay with that? All right, now, so that takes us through those first 4 questions. Here, we did something like this a little bit earlier, where we've got the graph and we want to calculate the slope. So what we need to do, now when I drew the graph, I emphasized 2 specific points. We need to find some points that are easily identifiable. In other words, we wouldn't want to pick that point and that point, but we might pick that one right there and that one right there. So here, I'm going to go down 1, 2, and over 1. So -2 over 1. You follow that? So the slope would be -2. Okay. Let's see here. That's more of what we looked at before. Oh, here's another one. So here's a point that goes through a nice number, and here's one. So it's going to go what? Up 1 and over 3. So the slope is going to be 1/3. How about this one? What's the slope of this going to be? undefined, right? Because it's a vertical line. Okay.
Hey, Mr. Mayo,
Yes.
you always count up or down first.
Yes, because up or down is a change in y. There you go, right? And I always tell people up or down first and then from left to right. Some people will teach you can go both, you can go either right or left, but I say always go up or down and then go to the right. So calculate the slope going from left to right. So up or down and then left to right. Now here it says match each graph with its slope. So you click on this. So after you've calculated the slope, you find the value amongst those and then choose that one. Okay, any questions about that? All right, now something entirely different. It says find the slope of the following line. And I'm not going to do this problem, but I'm going to do one similar to it. Okay. Let's say we have the following equation. 3x plus 4y equals 12. We're going to take this equation and we're going to solve it for y. Back in, I can't remember if it was in the last chapter or if it was in earlier in this chapter. I think it was the last chapter where we solved formulas for a particular variable. And we had some examples like this. And I emphasized a certain form, and that's going to come into play now. We're going to take this equation and solve it for y. So the first thing I'm going to do is isolate the y term. And I'm going to write the x term first on the right side of the equal sign, followed by the constant. Okay. So in other words, I'm not going to write it like this. Even though that is not wrong, it's not the form we want. Next, I'm going to divide each term on both sides of the equation by the coefficient of y. So now I get y equals negative 3/4 x plus 3. Now, this form is called slope intercept form. We're talking about the slope. We haven't talked about the intercept idea yet, and we'll get to that here eventually. But when it's written in this form, the coefficient of x is the slope of the line. So if we were to graph this line, it would have a slope going down 3 as it goes over 4. So by solving the equation in the form y equals something times x plus or minus some constant, we get it in that slope intercept form. Let me show you. Let's take a look here. Find the slope of the following line. And I'm just going to click on show detailed solution. So notice what's happening here. We're moving the 2x to the right, subtracting it from both sides. Then we're dividing everybody by 4. So the slope is negative 2 over 4, which reduces down to negative 1/2. Any questions about that? All right. Let's see here. Find the slope of the following line. We can't really solve that thing for y, can we? But what do we know about the equation of a line that's x equals a constant? It's a vertical line. What do we know about the slope of a vertical line?
It's undefined.
Right. So there it is. Okay. Let's take a look at this problem. Negative 5y equals 21. Well, let's see. If you divide it by negative 5, you'd have y equals negative 21/5. Well, X isn't even in the problem. So how can we read the coefficient of X? Well, could we write it like this? Would this be the same as that? Yeah. What's the coefficient of X? 0. Oh, Y equals a constant. That's a horizontal line. What's the slope of a horizontal line? 0. Okay, are you seeing how that all kind of fits together? All right, let's look at some other kinds of application problems here. It says the pitch of a roof is its slope. Use the picture below to calculate the slope of the roof. Assume the peak of the roof is in the center of the house and has the same slope on both sides. All right, so looking at this left-hand triangle, what's the rise going to be?
40,
Excellent. Now be careful. What's the run for this triangle?
44,
Right. So your slope or the pitch would be 40 over 44, which you could reduce down to 10 over 11. Let's see what it says here. Yep, 10 over 11. Okay. All right, let's take a look at this one. The city is considering building a commuter train. The steepest section of track has a fall of 52.02 feet for a horizontal distance of 289 feet. Okay. So it's got a fall of 52.02 feet and for a horizontal distance of 289 feet. What is the grade of this section of track? All right, a grade we use a positive number for, but notice the instructions, it says the downgrade. So the downgrade is going to tell us that it's going down, but we'll still use a positive number. All right, so I've got 52.02 over 289. Let's see. If we multiplied by 100 over 100, we get 5202 over 2890. Wow. Reducing that down, that's going to be messy. Let's see if I take 5202 divided by 2890.
I think you need another 0 on the bottom there.
I think you're right. Thank you. Okay. You know what? I get this. It does come out nicely as 0.18. That would be what as a fraction? That would be 18 over
100,
100, which would be what, 9 over 50? So our reduced fraction would be 9 over 50, and there's our 9 over 50, okay? But then it says convert it to a percent. So we'd multiply it by 100% over 1. 100 over 50 is 2 over 1. So it's going to be an 18% fraction, okay? Now, why don't I say negative 18%? Because right here, it takes care of that when it says it's a downgrade, okay? So you wouldn't put negative 18% there or negative 9/50ths because it's in the description as a downgrade. All right. Let's see here. Let's take a look at this problem. The graph depicts a relationship between scores achieved on an unspecified standardized test and family income. Take a look at this axis and this axis. See these little sort of Z's, it looks like Zorro was here. That's to say that there's some stuff missing in the graph. Likewise, something missing in the graph. This scale down here, income is in $250. So each one of these little hash marks represents $250. Each one of these hash marks represents what? 25, a score of 25 from 500 to 525. So what is the scale on the x-axis? You'd say 250s, okay? What is the scale on the y-axis would be 25s. And technically, the bottom should be $250, and this would be what? 25 points. Find the reduced rate. Okay, blah, blah, blah. We've got all that. Oh, I know what I want to talk about. So slope usually deals with things like numbers. Rate of change would be where there's units involved. So for instance, let's say this, let's say the slope is 30 or 30 over 1. A rate of change, it might be 30 miles per 1 hour. So with a rate of change, think back again to an earlier chapter, a rate has different units. So a rate of change would have units attached. Okay. So for instance, down here it says, what is the average rate of change? Notice it has, okay, it's got numbers, -6, but it's millions of dollars per year. So there's where the units come in. They've already written the units as part of the answer, but the average, so the slope would be -6, but the average rate of change would be -$6 million per 1 year. Okay, so slope has just a number ratio, rate of change, think of a rate, units. Okay, let's see here. Let's take a look at this one. It says, find the average rate of change of g of x equals 1x minus 5 between the points -3, -8, and 3, -2. Average rate of change. Let's see what they've got as an answer. They've just got a number. So they haven't put units on there. Oh, well. All right. So between the points, -3, -8, -3, -8, and 3, -2. Okay. How are we going to do that? Well, let's see. If we put in -3 for x, we get -8, right? If we put in 3, we get, hang on here, I'm putting in the wrong number. 3, we get -2, right? So those ordered pairs are solution to that equation, all right? Let's use the slope formula. So -2 minus -8 over 3 minus -3. So that's going to be what? 6 over 6, which is 1. So the slope is 1. The rate of change is 1. So we've got all this fancy language, but they're still just finding the slope. Okay. Let's see if there's anything else I wanted to do. We've done that. Here's the introducing the letter M. I think we're good. I think we're good. Okay. So that's all for today. You want to memorize that slope formula. M equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. You should memorize that going from left to right, if it's going up, it's positive slope, down, it's negative slope, horizontal, the slope is 0, vertical, the slope is undefined. You should memorize that y equals a number is a graph of a horizontal line, x equals a number is a graph of a vertical line. Okay. All right. I will be back at 1:15 should you have any questions. Otherwise, I'll see you tomorrow. I'm going to go ahead and stop the recording.